Thank you very much, MK. It's such a great honor to be here. I really appreciate the kind invitation. And what a beautiful room to actually give this talk in. So I find it very inspiring. As MK said, my name is Oshin Vartanian. I'm an experimental psychologist by training. I do work in cognitive neuroscience, and for the last 20 years, I've been sort of studying how the brain supports the creation of original content and the appreciation of that content. So these are essentially two different sides of the same coin. You can sort of study creative processes in the brain, and you can see how a person appreciates the products of that process. So given that I only have about 45 minutes today, I'm going to focus on the latter. So I'm going to be focusing on aesthetic appreciation. So for example, when you go to an art gallery, and you stand in front of a painting and you find a painting to be moving, what are some of the processes that are actually helping you have that psychological state? Now, if MK invites me next year, I'll come back and give a talk on creativity, okay? Okay, so before I start, I'd like to give you sort of like an outline of where I'm going to take you on this journey. So I want to start initially by saying a little bit about the origins of empirical aesthetics. So this area that I'm doing most of my research in these days is called neuroaesthetics. So neuroaesthetics is sort of concerned about understanding the ways in which the brain supports aesthetic experiences. So the ways in which we can do that now are sort of really managed and helped by some of the technology that we have available. So the very first studies that were published that looked at how the brain responds to, for example, viewing paintings came out exactly 20 years ago in 2004. So we have sort of like a 20-year history now to look to see what this body of work is telling us about how the brain supports the arts. However, the questions are much older, and they go back to some of the very early labs in experimental psychology in the 19th century. So I want to start there and kind of like walk you through the process to where we are here. Then the next thing I'd like to talk about is sort of like the bulk of this talk is what's called the aesthetic triad. So a few years ago, a really good friend and colleague of mine, Anjan Chatterjee, who's very active in this area, so he and I sort of reviewed the body of work that's out there on neuroaesthetics, and of course also empirical aesthetics, to see whether across all of these studies that have been done on visual art, music, dance, so forth and so on, whether we can see commonalities in how the brain supports aesthetic appreciation. And as it so happened, after many cups of coffee and discussions and reading through literature, it seemed like there were three different systems in the brain that together support aesthetic experiences. So the first system is the one that primarily deals with rewards and emotions. I'll be talking about emotions a lot today, so if you like that topic, you'll be in pretty good company. Then there are, of course, sensations and perceptions. You know, when you stand in front of paintings, there are all kinds of sensory and perceptual processes that are happening in your brain that, of course, elevate the experience. I'll be talking about that. And, of course, then I'll be talking about various kinds of larger background factors like culture and knowledge and context that also impact how your brain is functioning. So these three systems together in your brain underlie the experience that you feel to be aesthetic, okay? So I'll basically walk you through a bunch of studies to convince you that this model is probably a good model to go with, okay? And then I want to talk about a huge theme in this area that cannot be left alone, which is, of course, individual differences, okay? So very often in our lab, we have people go into the fMRI scanner. Oh, by the way, if you haven't had much familiarity with the fMRI scanner, I'm going to give you a 1-minute primer a bit later, just so you know what the signal actually tells you. But the person goes inside the fMRI scanner. Of course, we collect brain imaging data while they're viewing different artworks or works of architecture, so forth and so on. And we see a lot of individual differences, okay? And typically in the past, those individual differences were treated as noise, okay? But they can actually be very valuable sources of information for what's really driving preference in different people. Because of course, when a person goes inside the fMRI scanner, they bring their entire past history with them while they're interacting with the works of art. And of course, you use the brain as some kind of a medium to get a glimpse of what's happening there, okay? So I'll talk about individual differences. And of course, at the end, I'll have some conclusions, but what I'm really looking forward to is some good discussion. So I've kind of planned to end about 10 minutes early, so there'll be like a forum to ask, you know, some questions and so forth and so on. That'll be my favorite part of this talk, okay? Okay, so This person whom you see here, Gustav Theodor Fechner, he's one of the giants of psychology. So he is one of the best-known people who kind of did a lot of work. He's German. In the 19th century on a field that's referred to as psychophysics. Okay, so psychophysics is basically a branch of experimental psychology in which your primary job is to see if you can look at the effects of different kinds of physical properties of the world on psychological states. To give you an example, so for example, what I could do right now is I could, for example, vary the illumination in this room, okay, very systematically. And I would measure, for example, whether you notice differences in brightness. Okay, so that'd be one way to see whether some kind of physical feature of the world that's impacting your nervous system is actually having an effect on your psychology. Okay, because we know that our perceptions are driven by physical properties of the world. Okay, so in 1876, he wrote this absolutely beautiful book called Vorschule der Ästhetik, which in German means Preschool of Aesthetics, which is the defining text, kind of like the birth of the field. We're kind of fortunate to actually have a book that you can link everything to in terms of the origins of the field, in which he argued that psychophysical methods can be used to understand people's aesthetic responses. Okay? And the way you would do that, because he was a psychophysicist, would be, for example, to look at images that you would vary in contrast. You could look at sounds, for example, that you could vary in amplitude, and you could see how this is impacting how a person is perceiving them, and of course, whether it impacts preferences or not. Okay? Now, he argued that this is what he called aesthetics from below. And what I mean by that is, you start from a physical object, and that, for example, can be a source of sound or an image. You manipulate the object and you look at the effects in the human. So it's from below going up. Of course, another way you could study aesthetics is top down. So what that means is you focus on, for example, some of the experiences and background factors of the viewer that are impacting what the person is feeling. So as you will notice when I talk about all the brain imaging findings, there's been a long-standing tension about where the real locus of the action lies. Do you want to focus on the work of art and see how it's impacting the viewer? Or do you want to study features of the viewer that are impacting the quality of their experience? Okay? And I hope that by the end of this talk, you'll have as many questions as you did before, because it's an unresolved question. Okay? Okay. So a couple of old diagrams to kind of link the old work to the new work. So what you see on the left-hand side is a box there that says stimulus, and what you see on the right is what it says perception. Okay, so the idea here, this is kind of like the old Fechner model, where you kind of go to the stimulus, you make various kinds of changes there, and then you study perception. However, even at the time, Fechner knew that there must be some medium that connects properties of the object to the experience of the viewer, and of course that would be the brain. Okay, of course in the 19th century there was no way to in fact study the brain, but he already had the intuition that the brain must be very closely implicated in this process. So now we can fast forward about 100 years, and this is where we are right now, where that box in the middle, which is neural activity, is something that we now have access to. So now a person goes inside the fMRI scanner. For example, we manipulate what they're looking at. So for example, I do a lot of work on visual art. So for example, I can show you a representational work, and then I can show you an abstract work, and I can see which one you like more. But at the same time, I'm collecting brain imaging data on brain activation throughout the brain, and I can see whether data from the brain is helping me understand why you prefer what you prefer. Okay? And this is that critical intermediate link that you can use to understand processes and mechanisms. Because it's not necessarily the location in the brain that matters, but it's the structure that's activated, because they tell us something about what's really going on. Okay, so I've bandied and thrown around a bunch of terms. I want to do a quick definitional chart before we go any further. So one thing I've talked about already is neuroaesthetics. Okay, so neuroaesthetics is basically a field. You can sort of think about this field as like a newer, more updated version of experimental aesthetics, where there's a lot of focus on how data from the brain can be used to understand aesthetic processes. Okay, so for example, typically in our studies we ask about people's feelings while they're viewing works of art. So for example, I can show you an image, and I can ask you how much you like it. And then I can ask you to tell me something about how you're feeling while you're viewing it. Okay? Now, if I've got brain imaging data, I can look at a lot of the emotion centers in the brain to see whether activity in your brain, specifically in the emotional regions, is driving preference levels. And that can be very, very informative. So that would be sort of something you could study through neuroaesthetics. Now, perhaps a more elementary question is, what is an aesthetic experience? Okay? As it turns out, it's not that easy to define, but in its most general term, we think of it as some kind of an evaluation, some appraisal of an object that you're looking at. So aesthetic experiences can arise not just for art, but you can have them while you're looking at, for example, beautiful faces. Okay, there's a huge area of study. So a lot of us who do work on art also study facial attractiveness. And of course, when people look at faces, they very, very quickly judge their attractiveness. Okay, so that's also an aesthetic judgment because you're evaluating an object that you're looking at. The important thing to remember is that aesthetic experiences and evaluations can happen either explicitly or implicitly. So an explicit version would be, I have you go inside the fMRI scanner, I show you a work of art, and I ask you, tell me how much you like it, and you give me a reading on a Likert scale. It's very explicit. Okay? However, very, very often we engage in aesthetic evaluations completely implicitly. So for example, you come across a person, you may not be explicitly judging the attractiveness of their face, but in very often you tend to do it implicitly and very, very quickly. Now the fact that it's done implicitly doesn't mean that it means any less to your subsequent judgments. For example, there is a lot of evidence out there to show that, for example, people who are perceived to be more attractive tend to get paid more for doing the same job. Okay? We tend to associate all kinds of character traits with them. So we tend to think of them as morally more elevated. Of course, which is something which has nothing to do necessarily with facial attractiveness. It's done implicitly, but it can really affect subsequent judgments. So a lot of the work that I'll present to you today involves explicit judgments of art, but it's also important for you to remember that, when you walked into this room, there's a lot of beautiful art hanging here. You may not have necessarily walked to any of them and said, let me ask myself how much I like it. But the fact that you glanced at them may have very well affected how you perceive them and your subsequent reactions. Okay? The final thing that I want to touch on, because everyone who's here interested in art would think about that almost immediately, is where does beauty come in? Okay? So in a lot of our work, we tend to tell people, okay, I'm going to ask you to think about aesthetics. What is the first thing that comes to mind when you think about the term aesthetic? Okay? So typically, the first thing that comes to mind for a lot of people is beauty. Okay? So this is why we use beauty as one of our metrics to look at aesthetic judgments. So in the fMRI scanner, people are asked to, for example, tell us how beautiful an object is. We tend to probe their preference levels, how much you like them. But beauty holds a very special place because it's philosophically a very important concept. And a few years ago, we did basically a big review of this literature to sort of see where the overlaps are. So there is what's called the cognitive neuroscience of aesthetics. So remember, this one sort of is involved with how are you evaluating and appraising objects. Okay? Then there is a cognitive neuroscience of art. Okay? This is where you very specifically look at art objects. Okay? Because of course you can have aesthetic reactions to other things that are not art. And you can see somewhere there is a cognitive neuroscience of beauty. It overlaps with them, but is not the same. Because you may not necessarily be making a beauty judgment, you could be making some other kind of judgment. Okay? I hope everything is clear so far. Okay, please feel free to interrupt me. It's perfectly fine. Okay, so this is basically the model that I was talking about before that Anjan Chatterjee and I proposed a few years ago. It's called the aesthetic triad. Okay, so as you can see, the aesthetic triad, not surprisingly, has three components. Okay, so one of the components is what you see at the bottom right, which is emotion evaluation. So these are neural systems in the brain that are involved in emotional processing and how you value things, the reward systems in the brain. Okay, so this seems to be a very core aspect of how we're interacting with art. And this system in the brain, as you know, is evolutionarily very, very old. And one of the really, really interesting things about the story of art is that a lot of these old evolutionary systems within the brain that probably evolved for very different reasons initially were eventually co-opted to help us appreciate art. See, from an evolutionary perspective, it doesn't make sense that you've got a reward system in the brain, for example, for food or for sex, and then art comes around evolutionarily, and your brain somehow creates a completely new module just for brain. That doesn't make, it's a very evolutionarily costly thing to do. What makes much more sense is that you've got an old system in the brain that's just co-opted for a new function. And as you can see, when I talk about a lot of the brain imaging data, if you look at what's happening in the brain when a person experiences the flavor of chocolate, listens to music that gives them chills, looks at a work of art that they find beautiful, or has an erotic experience that's intense, it's the same reward system. Okay? One reward system co-opted for different things. Okay? The second thing I'll be talking about is the sensory motor system. So I've already kind of touched on this before. So when you look at works of art, even many examples in this room, for example, they have a particular sensorial impact on you. So for example, when I look at those cowboy boots in the end of that room there, you look at those shapes and you have a visceral reaction to them. Okay, so of course that's done purposefully by the artist. Okay, to evoke that reaction. And then you can look at the brain's sensory and perceptual system to help you understand what does a person like or not like them. Okay, and the third system is the knowledge meaning system. In some ways, I think the most interesting system. This is sort of the larger sociocultural background and contextual factors that impact how you interact with the work of art to begin with. Okay, so when you go into a museum, we all go to museums very often. We don't go to them as the same person. There's loads and loads of individual differences. We carry our past history with us into the museum. Okay, and a lot of these past historical, cultural, contextual effects really color what we like and don't like. Okay? And historically, unfortunately, these particular factors were not studied very heavily, but now I'd say they probably have become the most important topic of study in neuroaesthetics. Okay? And not surprisingly, these three systems that I've just talked about do not overlap in the brain. So you can really, so this is basically a pictorial representation of the three systems that I've talked about in the brain. Oh, by the way, if anybody wants to have a copy of my presentation, I'll be very happy to share it with you. Yeah, so you can sort of look at the aesthetic triad, and this one is kind of like a pictorial representation of what I just talked about. So in other words, these neural systems in the brain, of course, there is always overlap. These are not completely distinct systems, but you can actually dissociate them, all right? Okay, very good. So the next thing is my 1-minute primer of, my favorite instrument, which is the fMRI scanner, which I happen to find to be a very aesthetic object. Okay, so, one thing you may ask yourself is, okay, so Oshin gets all of his data by having people go inside the fMRI scanner. Is this even a valid environment for studying how much people are impacted by art? And this, I think, is a very valid question. I was just at a museum a couple of weeks ago. You walk around, you come across this beautiful work of art. I can sort of sit there, I can contemplate the same work of art for extended periods of time. I can walk around and look at other things, and then I miss the thing that I really liked, and I tend to come back to it, and I sit there for a little bit longer. It's especially good if you go to the museum with a friend, especially if it's a friend you get along with. And you can have like discussions about the things that you've seen. So these things, of course, you can't do in the fMRI scanner. So typically in the fMRI scanner, because of the temporal resolution, a person will look at a work of art for just a few seconds. So we're kind of looking at that immediate sensorial response that takes a few seconds to build up, because otherwise the biological signal degrades and it's not very useful. However, this is sort of the best thing we have right now for looking at what's happening in the brain. Now, next question. What does the fMRI signal actually tell you? Okay, so this is like a 1-minute primer on fMRI. So you've got different structures in the brain, each of which will do different things. Say I have a person go inside the fMRI scanner and I show them things through the visual modality. So the idea there would be that the visual system has to work harder to process what the person is looking at. So the visual system at that particular moment in time has a higher metabolic demand. It needs more energy. So how does it consume the energy? You need to deliver oxygen to the regions of the brain that need to work harder to be able to do the kind of processing that they want to do. So how do you do that? There is increased blood flow to the regions of the brain that require it for metabolic demands. So there's increased blood flow to the regions of the brain that need it more. Then there is transfer of oxygen from the blood into the cells. The cells grab the oxygen, use it for energy, and whatever they haven't used, they dump back into the bloodstream. Okay? So the movement of oxygen into the cells and back causes a momentary shift in a magnetic field, and that's what the fMRI signal tells you. Okay? So it is not a direct measure of what the brain is doing, but it's a very highly correlated indirect measure. So everything I'll be talking about today in terms of brain imaging is correlational by design. Okay? So it's a correlational method. It's got its pros and cons, and I'm very open about what the cons are, but they also come with some pros. Okay? Okay, great. So now we're going to do our little tour of the data. Starting with my favorite system, the emotion valuation system. Okay, so now what I'm going to do is, I've sort of told you a story. You're probably not fully convinced. So what I'm going to do right now is I'm going to walk you through some of the key studies. There are of course a ton of studies in this area. If you really want to read more of them, I'll be very happy to send you papers if you care about them. So I've picked the ones that I think really kind of help me tell this story, okay, to kind of convince you that some of the things that I've told you so far actually have an evidential basis. So this is the first study that we did where we had people go inside the fMRI scanner and we showed them a bunch of paintings that were either representational or abstract. Okay? Now remember, as I mentioned to you before, people tend to prefer very different things. So what you don't want to do in an fMRI study is only show art from like one category or one epoch of time. You're going to have a couple of people that tend to like what you're showing and everybody else will hate it. So you want to have a good diversity of things that you show. So in this one we had many dozens of images that we showed. And the person had a very simple task. Using a Likert scale, they told us how much they like them. Okay? So this in 2004, if you remember earlier, I said how in 2004 the first 3 studies in this area came out. At that particular point in time, we had ideas about what the brain might tell us, but we hadn't actually seen anything yet. So we had some predictions. And of course, what people always tend to predict with all of these studies is that we're going to see activation in the prefrontal cortex. For some obscure reason, everyone's in love with the prefrontal cortex because it tends to be the area where a lot of higher level cognition happens. And of course, us being really into art in this lab, we thought, well, you know, the only way that you can really understand a really major response to work of art is that it has to involve higher level function. So what we did is we looked at the data, and the data told us something very different. So we had 3 regions here. So the regions that you see here are the caudate nucleus. We saw activation in the visual areas, and we saw activation in this area called the cingulate sulcus. These are all old regions of the brain that are involved in processing reward. So for example, when you consume chocolate in the fMRI scanner that you consider to be very tasty, the same areas light up. Okay? These are evolutionarily very old areas. We saw nothing in the prefrontal cortex. And then there were a couple of other studies that sort of came out around the same time, kind of showing largely similar story, that it's primarily reward and emotion centers in the brain that are playing a major role in how much people like visual art. Okay? And then in a subsequent study with Jerry Kupchak, also from University of Toronto, with whom I've done lots of work in this area, we had a slightly different design. Think about this design. People went inside the fMRI scanner. Now they're seeing, again, images of art from different epochs of time, but under two different conditions. In the aesthetic condition, remember, the aesthetic condition, before you see the images in the fMRI scanner, the person's told, when you view the next images, I want you to really focus on the emotions and the feelings and the mood that the work evokes in you. Kind of like the orientation you would assume if you went to a museum and you were kind of open to really taking all of that emotional repertoire in, okay? Then in the second condition, which is what we call the pragmatic condition, is you kind of take an everyday information processing approach. So you look at a painting, you look at objects you can recognize, oh yeah, that's a face, or that's a suitcase, or that's a tree, or that's a scene. So there's the aesthetic orientation and the pragmatic orientation. Now, as you know, in our everyday life, and this is what keeps us alive, we're primarily in the pragmatic orientation. Okay, so if you were perpetually in the aesthetic orientation, you would not survive very long. So the pragmatic orientation is very helpful. But you do want to switch when you need to. So what we found here is what you see on the left-hand side is regions of the brain that are involved when a person is in the aesthetic orientation. And the activation that you see in the front of the brain is in this region of the brain called the insula. So I'm going to be talking about this area a lot, the anterior insula. The anterior insula is very heavily involved in visceral experience of emotions, okay, including unpleasant emotions like pain, for example, or anxiety, or disgust, but also intense positive emotions. So when we ask people to interact with works of art in the aesthetic orientation, the insula popped, okay? And then what you see on the right-hand side, which is what happens when a person looks at artwork from a pragmatic orientation, this is a cingulate, and this is an area of the brain that's really involved in attention. Maybe not surprising because a person is told to attend to things and see whether they recognize objects or not. So we saw a dissociation based on the same works of art, just the orientation, okay? Then the next one, the next image that you see here is basically, again, a direct comparison of those two conditions. Again, you see the anterior insula really pops as the one area that's really driving the difference between the aesthetic orientation and the pragmatic orientation. So again, we're like, oh my God, there's something really going on here. Emotion and reward are like key drivers of what people like, okay? Then a few years went by and a good colleague of mine, yes, go ahead. See, I love this question because that's an experimental psychologist question. It's a beautiful design question, and thank God I have the answer. Yeah. So typically with studies of this kind, we tend to present them in blocks. So the idea is that, for example, the person is asked to go into an aesthetic orientation, and then they see a sequence of images, and then we have a gap in scan time, and then we've got the next condition, and then we've got a block of images, because, exactly to your point, it's very difficult to switch back and forth. And of course, the same thing happens when you go to a museum, okay? So I was recently in Vienna. I went, you go into a museum, and it's absolutely beautiful. You're in this museum mindset. And I find that even when you leave the museum for a while after you've left, you're kind of in that mindset. You're kind of like walking outside, but it's almost as if, even though you've switched physical locations, psychologically your mindset hasn't quite shifted yet because of that reason. So you kind of have to allow people a bit of time to switch. But yeah, that's an excellent question. Very good. Yeah. So a few years later, Stephen Brown did what's called a meta-analysis. So remember, this is now 2011. We're kind of like walking through time. So what he did in this study is that he kind of looked at all the studies that have been done to date on aesthetic appreciation, the visual domain. And I've got a list of different objects that he looked at. So there were artwork, faces, general pictures, erotic images, food images, images of loved ones, people that you care about, friends and family and so forth. And the question was, how about we do a meta-analysis? So what you do in a meta-analysis is that, of course, all of these individual studies, like the ones that I've shown you so far, are going to give you a slightly different picture of what's happening in the brain. So what you do in a meta-analysis is that you amalgamate all of those data together to see what's a reliable pattern of activation across studies. So as you can see, a large number of regions in the brain are involved in aesthetic appreciation, the overwhelming majority of which fall within the emotion reward network. So it's not just a couple of studies that I've talked about so far, but even when you look at a lot of studies over time, you see a similar pattern. Okay, so let's see what's going on here. So this is the reward system in the brain, okay? So this is what's called, and this is a term that I want you to keep away from this. If there were a couple of terms that I hope you'd remember a week from now, is the common currency hypothesis. So the common currency hypothesis is this idea that when you look at people experiencing all sorts of rewarding things in different domains, so those could be art, it could be erotic images, it could be food that you really like, it could be scenes that you find particularly beautiful. The same core regions in the brain that process reward are activated. And this system is evolutionarily very old. You can imagine how our ancestors would have probably really benefited by having this system in their brain, because it would promote and motivate them to seek things that help survival and reproduction. Okay? Yes.
Just what you just said right there as well, mentioned like the old parts of our brain. So for the lay person, like our brains have evolved into other higher thinking or abilities versus some parts we just don't use. I know we don't use a lot of the brain.
Yeah, so the brain that we have right now evolved differently over time in different stages. Okay, so there are certain parts of our brain that are evolutionarily newer. So for example, the prefrontal cortex is evolutionarily newer, okay, than some of these core reward regions. And they probably evolved because the demands for human survival changed over time. And the brain had to accommodate that and develop differently over time. Okay, but that is a very good question that you asked, because depending on where you see activation in the brain, not only tells you what is happening now, but it tells you something about the evolutionary past of the effect that you're observing now. Okay, so if what you're seeing happens in the prefrontal cortex, it's easier to make the inference that this is probably a more recent adaptation of the brain because it's being instantiated in the prefrontal cortex. But if it's happening in a very old region of the brain, you can, for example, make the inference that this probably was also relevant a very, very long time ago to survival. So, for example, one area, so MK, probably another future visit, that I do a lot of work in is, I do a lot of work now on a neuroscience of architecture. Okay, so for example, if you find yourself, and I love this room for many reasons, but if you, for example, sit in a room like this, there are all kinds of factors, for example, how high the ceiling is, whether you can see everything or not, how curved is the room versus how rectilinear is this room. So all of these geometric features impact our brain function. And the idea there is that a lot of these features aren't features that are necessarily relevant to new architecture only, but they were features that in our evolutionary past help us survive in the environment we were in before. For example, curvature of the room, or the extent to which you could see predators coming in and you could seek shelter. These are things that you can still design into modern architecture, but the drivers are very old. Okay, so you can sort of see the evolutionary arc of the effect that you're interested in, you know, which of course, if you care about the brain, is always a very interesting part of the story, you know. Oh, excellent questions. Okay, so the next one, sort of like a similar idea. This is like, so the one that I showed you before had to do with reward. This is more about emotion. So again, another term you may want to jot down is this idea of core affect. So the idea that we used to have before is that there were all these very discrete emotions. So for example, anger, surprise, happiness, so like basic emotions. And the idea was that the brain would have different modules for each of these emotions. That's in fact been shown not to be true. What is true is that we have a core system in the brain that's engaged in almost all the emotions that we're interested in. Of course, your personal experience of emotions varies because your interpretation of that physiological signal is impacted by things like context. Okay? And the way you interpret that signal and your mental representation of that signal allows you to feel different categories of emotions. But the systems in the brain that compute them are common, thus core affect. All right? Now, this brings us to a very important image. I realize I'm running a little behind in time. I always tend to go on a little bit. So maybe I will go through the next parts of my talk a little faster and skip some parts, but this is an important one I do want to spend some time on. So this is what's called the brain's pleasure cycle, okay? Pleasure cycle, very important. So two things that people tend to not distinguish very often consciously, but they're very different things, are wanting and liking. Those two things are not the same thing. Okay? So there's loads and loads of physiological data to show that the systems in the brain that underlie wanting are different than the systems in the brain that underlie liking. We tend not to distinguish them very often because they tend to co-occur. You know, we tend to like what we want when we consume it. Okay? So what you see here on the y-axis is amount of pleasure. Okay, so that's your y-axis. And what you see on the x-axis are three phases of interacting with an object that ends up being pleasurable. Okay? So in the first phase, what you see is approach behavior, which is wanting. Okay? So what you see there is, for example, you have an increase in arousal. So for example, this is when a person views an object that they desire. Okay? So the experience that you have psychologically is wanting. Okay? So you approach it. You're not necessarily experiencing higher levels of pleasure. Okay? So you can see the pleasure curve is flat and it's just beginning to go up. So the first phase is wanting. Then the second phase is when you're actually consuming the object. Okay? So this is what leads to the experience of liking in the brain. Okay? You're liking what you're consuming, and there's a huge increase in pleasure, okay? And as you can see, this image comes from studies of sexual behavior, so it peaks at orgasm, okay? So you have a wanting phase, followed by a liking phase in which you consume the object, and then there's a very, very important third phase, which is a refraction phase, where you think about the experience and you learn from it, okay? So every single time you have the desire to approach an object, and you've consumed the object, the extent to which you've actually experienced pleasure consuming it allows you to update your memory system and you learn something from it. Okay, this is essentially called, experience-dependent plasticity. Your brain changes because you've learned something through the interaction. So something very, very similar is now considered to happen when you experience art. Okay, so of course the image here, as I've shown you right now, is about orgasm, but it's a very similar thing where you view a work of art, you're consumed by this desire to approach it because you want more of it. Then you interact with the work of art, and you can think of that as consumption. Okay, and while you're consuming the work of art, all kinds of things are happening in your brain, and of course the moment you disengage from the work of art, a lot of learning happens because you tend to contemplate the experience that you had. You're not really the same person. You're a slightly different person because your brain learned something from it. Okay? And I would like you to think of yourself interacting with work of art kind of around this pleasure cycle. It's a very reliable phenomenon. It has a lot of biological reality. Okay? Right now, there's huge amounts of work being done about the extent to which feelings of wanting and liking can be dissociated in the context of art. Okay? But it's an important one to keep in mind. All right? Now, so since I'm clearly running a little out of time, I'm going to talk about this study very, very quickly. This is a very beautiful study that was just published by Efticia Stamkos. So she works at the University of Amsterdam. So remember, everything that I've talked about so far kind of has to do with like very simple emotional states and preferences. Do you like something? Do you not like something? Do you prefer it? Do you not prefer it? But we know that when we're interacting with art, we tend to have a lot of complex emotions. So she had a beautiful study where she showed people thousands of images from different eras. So this one here will show you all the different countries and all the different epochs of time from which the stimuli were drawn. And people looked at these art images and said, first and foremost, whether they liked them or not. And then they rated them on all kinds of emotions. And the emotions that she looked at are far more interesting than what I typically look at. Okay, so let me read you what she looked at. So people rated things on admiration, adoration, amusement, craving, cringe, curiosity, desire, fascination, grief, shame, shudder, wonder. Okay, very interesting emotions that we tend to feel when we go to the museum or even in our everyday lives interacting with art, but we typically tend not to ask people. Because she wanted to see whether there is some kind of a framework for these complex emotions while people are viewing art. And the beautiful image that she generated here is that a lot of these emotion states are blends. So when we interact with work of art and we're telling people how much we like them, we tend not to talk about discrete emotions. So for example, if I tell you, well, how much did you like this Vermeer painting that you just saw? It's very unusual for you to say, I only felt surprise. So what were you doing? Yeah. So typically they're blends, and what she showed here is that they're blends of emotions, but they're not random blends. They're systematic blends. So if you get a copy of my talk, you can go and look at her paper. She kind of beautifully delineates these blends of complex emotions. And I think it really resonated with me because it's kind of how you feel when you see art. It's not simple, it's not discrete, it's actually quite blended. And then this very good colleague of mine, friend and colleague, Yoed Kennett, so he did a slightly different study because another theme that's become very big in this area is aesthetic emotions. Are aesthetic emotions different than other emotions? There's now a major discussion going on in the field about there are people that fall into the aesthetic emotion camp. They're like, there's something about art that's unlike everything else. And then there are people that are generalists, that think that, well, there's all these emotions that we have that in a context of art might be experienced differently, but there's nothing about the emotions per se. So not surprisingly, I'm kind of more in the general camp. But what Yoed did is that he showed that the context really matters. So he had people reminisce about episodes that were either aesthetic, so for example, you watched a movie that you found to be very moving, or they were non-aesthetic. And of course, the primary non-aesthetic one that people tend to think about, it's sport. Okay, this is what we tend to do when we're not at the museum. Okay, and then the third one was kind of like consumer behavior. You're out and about buying things, and it was able to show that what you see is you see the same emotions, but the constellation of the emotions is different. But people tend to report different things. So when people are thinking about the aesthetic experiences, themes that come up are like experiencing and feeling. But when they're thinking about non-aesthetic areas, it's more thinking and remembering. And of course, in the consumer area, it's buying and wanting. So the same emotions blend together differently to give rise to these psychological states. And he produced absolutely beautiful structural maps like these where you can actually visualize how the different parts of the emotional network relate to each other. Okay? Now, I've gone grossly over time, so I'm gonna do the next two parts very, very quickly, probably not even really going through a lot of my slides. Okay, so I've talked about the emotion valuation system. The next thing I want to talk about is the sensory perceptual system. So here I've shown basically a lot of images of things that I find to be viscerally moving. Okay, these are Fontana's cut canvases. You can see how he's even producing them. So when I look at this art, I find it's a very visceral sensory experience for me. Okay, so you can look at this beautiful painting by Van Gogh. You can see there's a lot of implied motion. Even though there's nothing moving in the painting, it appears as if things are moving. This is pointillist art. When you look at this art, you can't help but think about what the person went through making it. Okay, And of course, Caravaggio, if you haven't been moved before, you have to see a Caravaggio. I find this to be so visceral, you know, like when you look at this work of art, it's kind of has a real corporeal bodily component to it, okay? So the question is, are there systems in our brain that are in a sensory perceptual domain that respond to phenomena like this? And the answer is yes. We have a lot of systems in the brain. Go ahead. Yes. Yes. So that's a very good question. There are no studies that I'm aware of, but I have had a lot of conversations with colleagues who are thinking about doing work in this area. Great, great. If you have ideas about how this could be done, please come and have a chat with me. I'll be around and about consuming cake. Okay, so. Yes, so please make a point of that. Thank you very much for that. Yeah, so the question is, because I don't have a lot of time to go through the individual studies, unfortunately, so there's a lot of really good data now about how our brain's sensory and perceptual system is really responding to things that I just showed you, okay? And the one image that I want to speak about quickly is this one, which is something that you may have heard about before called, so the question is, well, why is it that we respond the way we do to images of this kind? So you may have heard about the mirror neuron system. So the mirror neuron system is a system in the brain that was first discovered in macaque monkeys. It's considered to be one of the most important discoveries in neuroscience. So amazingly, you can do these physiological recordings of the brain of a macaque monkey, and you can see that regions of the brain that respond when the macaque monkey grasps an object are the same regions of the brain that respond when the macaque monkey views a person grasp an object. Okay, think about how amazing this is. Okay, so in other words, you've got this system in the brain that isn't just responding to, okay, I'm going to be doing something myself, but you are responding to another person instantiating the same act. This is why it's called the mirror neuron system. So it's almost like you've got this simulation model in the brain that's running on the same grid. Okay, so there's a lot of really interesting work being done in neuroaesthetics right now about how this particular system might be the reason about how we empathize with works of art. So for example, when you look at that Caravaggio painting, and I feel pain, okay? Because when you look at that person, you know, having this like very corporeal experience, it might very well be that your brain is simulating that, and of course that allows you to really sensorially feel what's depicted representationally. Okay, so mirror neurons, have a read about that. So the final thing is the, which I'm going to skip through very, very quickly, is the knowledge meaning system. Okay, and the knowledge meaning system is the one that I talked to you about before, about all of these background and cultural factors that come into play that impact how we view things. So the slides that I just jumped through are the ones where people go inside the fMRI scanner and we show them art, and either we tell them this is actually made by an artist, or we show them the exact same art and we say this art is computer generated. Remember, the person's looking at the exact same work of art, and we find that when you tell a person the work is computer generated, they tend to like it less, and the regions of the brain that respond to reward are deactivated, even though they're looking at the same thing. Okay, same idea, for example, if I showed you images of Rembrandt paintings and I tell you, regardless of whether this is true or not, whether the Rembrandt that you're looking at is a real one or a fake one, because we know a whole bunch of fakes exist out there. The moment the person thinks of it as fake, they tend not to like it. It's the same work. Why is that? Because the context within which the same stimulus is experienced is very, very important. So Ida, I don't know if you've heard about her, she's the first super, super famous AI humanoid artist. I spend a lot of time these days looking at videos of her making art. And the amazing thing about her, so you can look at an image that she recently made, and they now go on sale for insane amounts of money. And the amazing thing about this humanoid AI artist is that she has, so the eyes aren't just there for show, they actually receive visual input that's fed into a computer. So when Ida is scanning a room, she gets a lot of perceptual input from the room that goes into an AI-run model that allows her to create models of the world using which she can actually draw. Okay, so the question is, for example, if I told you this work of art was produced by Ida, would you like it any less? Would you value it any less? And these are some of the more important sort of larger issues that come into play, not just about art, but about how we value a lot of things that are related to art. Okay? Individual differences. A quick thing to show you about individual differences is that, so this is basically an image that shows you how much individual differences we see when people look at different categories of objects. Okay, so we know that when people look at objects that are scenes of nature or faces, we generally tend to find the same things attractive. Okay, but when we look at objects that are made by humans, is where you see a lot of individual differences in what people like. And they can be works of art, sort of, visual art, but it can also, for example, be things like architecture. So once the human element comes in, you see a lot more individual differences. But that's really great because you can actually exploit that to study what's really driving those individual differences from a socio-cultural perspective. Okay, things like, scenes in a natural world and faces which primarily have a biological import, we see less individual differences in. Okay? So now I'm going to quickly go to my closing slide. And as I mentioned to you before, all of my slides I'll share with you. But I do want to hammer home a few main themes before we have a little discussion. Common currency hypothesis. So we tend to think now that there's a common system in the brain that is responsive to reward that helps us appreciate art. Okay? Let's discuss. Question number 2. There are lots of top-down and bottom-up effects. So top-down effects are things like social cultural effect, what you bring into the aesthetic experience. Bottom-up effects are things that really come from the work of art. So about 15% of what we like is determined by bottom-up effects, things having to do with the stimulus itself. About 85% is what the person brings into the experience. So if you want to see evidence for these numbers, I'll send you some really good papers to look at. So the context, very, very important. Okay? The next thing is we see huge amounts of individual differences in people like. I think this is a beautiful thing because it's a huge opportunity to see. Because for me, the person at a particular moment in time is, of course, of some interest. But what you really care about is the history of that person that led the person to be to the point that they are and how that impacts the data that you're collecting. So you don't want to just look at what's happening in the brain, how is the person responding to what I'm showing the person, but you want to also get info about the person's history and past and culture to glean further. Yes, go ahead. So we do ask a lot of questions about neurodiversity. Okay, so and those questions are taken into consideration when we analyze our data. But we don't, I myself have not really worked with anyone so far who, for example, specializes in neurodiversity. There's certain kinds of questionnaires that we use in imaging data to give us a sense of how the person is before we scan them. And this is where I think this work could get much, much better because what's done so far, I think, is a very minimal chunk of what needs to be done a lot more of. So if you have any ideas about how to kind of expand this work or to move it further, by all means, I'll be very, very interested. Okay? And the final thing that I unfortunately couldn't touch on very much, but again, if I'm back to speak about creativity, I will, is that what's been shown to be the biggest motivator for why we even interact with art is the search for meaning. Okay? So when an artist makes a work of art, there's a message or an idea or a concept that the person is trying to communicate. Okay? And when a viewer interacts with the work of art, of course you're dealing with some of the superficial features of the work, the geometry of the work, things that are depicted, colors and so forth, but you're kind of searching for the kernel of the work. You're trying to make connection with the original idea from the artist that really led to the creation of the work to begin with. So the search for meaning is huge. Okay? And when you look at aesthetics, you kind of have to look at that within that broader scheme of the search for meaning. Thank you very much, and I think we're at the end of my time.
Yes. So we're going to take a moment. Yes, please.